This next review video for Chapter 4, we're going to review Section 4.6, Performing Operations with Complex Numbers. So again, looking at the chapter review from your textbook on page 321, let's look at problems 30, 32, and 34. Before we get to that, I think it might be a good idea to review a few basics from complex numbers. So the first thing we need to review real quick is, what does a complex number look like? Well, remember, that's a highlighter. Let's get rid of that. Okay, go back to pencil now. Okay, so basics. A complex number is written in the form of a plus bi. Okay, there's a real part and there's an imaginary part. Okay, the basics for the imaginary number is we define I to be the square root of -1. Thus, I squared is equal to -1. So that's basically what we need to know in order to simplify complex numbers. So taking a look at number 30 from the review, we have the number 5 plus I, okay, times the number 4 minus 2I. So in reality, this problem is just a binomial times a binomial, so we're going to FOIL, or I like to just distribute. So we're going to take the 5 and distribute to both terms. And then I'm going to take the I and we're going to distribute to both terms. So doing so, 5 times 4, we get 20. 5 times -2i, we get minus 10i. I times 4, we get positive 4i. And then I times -2i, we get -2i squared. Next step, we need to combine like terms. So we have 20 minus 6i minus 2i squared. And then our last step is, we can't leave I squared in our answer because I squared is -1. So we need to rewrite this by taking out the I squared. We have 20 minus 6i minus 2 times -1. So we have 20 minus 6i plus 2. And then combining like terms, we have 22 minus 6i. And then notice how we always write the real part A plus the imaginary part second. So this is how we always write our answer, 22 minus 6i. All right, let's take a look at number 32. So 32, we have the number 8 minus 6i plus the number 7 plus 4i. So, key. Notice in between the two parentheses is a plus sign. We are not multiplying. We are adding these two numbers. So in reality, remember the key to this problem is we're going to do reals to reals. And then we're going to do imaginaries to imaginaries. So basically combining like terms. So this problem becomes 8 plus 7. And it's the real part, plus the imaginary part, -6i plus 4i. So 8 plus 7, I believe, is 15. And a -6i plus 4i, we get minus 2i. Again, written in the form a plus bi, and then there is your answer. All right, let's take a look at number 34. So 34, we have the number 4i divided by -3 plus 6i. All right, the other issue with this problem is we can't have i's in our denominator. So we need to fix this by multiplying by the complex conjugate. The complex conjugate of an imaginary number is simply going to be -3 minus 6i. So notice the only difference is the sign in the middle. And we have to do that to both the numerator and the denominator so we don't change the problem. And then remember, around fractions, there's really a set of parentheses around both of them. So what we need to remember to do is distribute. Okay? So the numerator is going to give us -12i minus 24i squared. And the denominator, we're going to, again, FOIL, or distribute. So we have the -3 distributed gives us the 9 plus 18i. And then we're going to go ahead and distribute this. So we have minus 18i And then we have minus 36I squared. Now, simplification here. Remember, I squared is going to become negative 1. So that happens in both spots. And this plus this is going to give us 0. So, we have on the numerator negative 12I plus 24. In the denominator, we have 9 plus 36. Continuing to simplify and then rewriting my order, so we have 24 minus 12I in the numerator. In the denominator, we're going to have 44. And we're almost done. The last step we like to do is divide out each term in the numerator by the denominator. And then simplifying, so we have, hope I added everything correctly here. 9 plus 36, oh, that should give me 45. That's my mistake. So let's get rid of this. Okay, so that should have been 45. Okay, so 24 over 45, I think we can divide both by 3, and that's going to give me 8 over 15, minus 12 over 45. I think we can divide both by 3 again, and we're going to get 4 over 15i. And we need to write it in this form. Again, remember, complex numbers come in the form a plus bi, so that's why we must separate the fraction. And that is a quick review of complex numbers.